Just text him, man.
Text him.
Good.
Howdy, Lance.
Howdy. Had to make sure that was you. I had to guess.
All right, let's get out our
Notes.
Oh, wait, I don't think we had that notes last time, did we?
No,
I,
Mr. Beach.
I gave you the homework, but I didn't pass out the notes.
Great.
Mr. Beach, remember how the other day you were explaining how like the colder it is, the more people like pay attention? Is that why your room is like frigid right now?
I like it cold.
I hate it.
I said it as low as I can. Right now it's about 67.
That's it. It's actually warm. It feels good.
Give us jacket on.
I can take it off, and it's still warm.
Why? It's too hot.
I always, like I said, I think it's like somewhat ironic that like, if you look at the school, every room is probably within 1 or 2 degrees the same, 68.7. 1 or 2 degrees all year the same.
Except for Mrs. Mouse.
So, well, no, I'm not saying every room's the same, but I'm saying the temperature in here is pretty much exactly the same all year. The cafeteria is the same all year. But in September, you're all in shorts and t-shirts, and now you all have like sweatpants on and hoodies, and yet the temperature in here is pretty much exactly the same year-round. And even the warmest rooms are maybe 72, 73.
Maybe it's because
And the coldest rooms like this, maybe like 68, 67, like 5 degrees different. Now, some of the rooms on that side, if they're in the sun,
that's what I was.
will get warmer. But
Yeah, Mrs. Brunker's room was
Hot today.
Yeah, Mrs. Brunker's
So-
always been warm too.
all right, yesterday we started talking about this. I'm going to skip the first part on here. I got rid of all that on your homework, so I'm just going to skip that here too. We started talking about what it means to be explicit. Did we talk about that in here?
Yes.
So, what does explicit mean?
Like on front and no relation meaning.
Explicit means clearly expressed, demonstrated. Okay, we're kind of down, about halfway down the bottom here. It says explicit definition of a sequence.
Oh.
So, explicit means clearly expressed, demonstrated, or straightforward. So, as we talked about yesterday, when they have music has an explicit sticker on it, that just means it's very clear, straightforward what it's talking about. There's lots of songs that have sexual content or talk about other kind of things, but it's implied and you kind of like, oh, you know what the meaning is. That's not marked explicit. Where something that is explicit is very clear. Yeah.
Did Luke understand what the birthdays were? Or did he not?
That the
On that
what?
one thing. Did Luke know the birthdays for that pattern?
sequence.
I don't know. I didn't ask him.
Oh, you didn't?
I didn't ask him if he even. I honestly don't even know if he even paid attention to the video. I don't know. I think so. I think he did in those. I don't know. I didn't ask him if he got it. So what we want to look at is a explicit definition of a sequence. What an explicit, and at this point, let me just say, this is all we've looked at. So at this point, you don't have any frame of reference to say what's not explicit. But an explicit form of a sequence is a sequence that's based on n. So if we have a formula here, and I say, well, what is the first term? You plug 1 in and you get 9. If I said, what is the 5th term? You put 5 in and that would be 5 squared is 25. Times 2 is 50, that would be 57. Right? And we could find the 100th term, which would be some big number, right? You can find just any term you want to. That's explicit. Compare that a second. With Fibonacci sequence that we talked about. This is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, so forth. If I wanted to find the 100th term, how would I find the 100th term? I would have to know what the 98th and the 99th is. we don't have a formula just to get to a specific term because it's based on the last two. This is not explicit. This is a formula that's going to be called something else, which is going to be called recursive. And that's what we want to look at here today. Something that you can't just plug in and get your formula. Now, is it possible to find a formula for this?
Sure.
That is that way? And we'll end up there by the end of today, but we're not there yet. So let's talk about a recursive definition of a sequence. For a recursive definition of a sequence, you need two things. Starting point and a formula. Do me a favor and underline starting point. Now, circle starting point. And now put a star next to the starting point.
Starting point important.
This is the part people always forget.
Oh.
9 times out of 10 when people miss points on these problems is because they forget about the starting point. Okay? Think of a recursive definition as like directions. If I'm going to give you, somebody's going to give you directions to their house. And they say, well, at the first stop sign, you turn right. And then the first street, you take a left, and we're the third house on the right. Okay, nowadays you don't even do directions, right? You just go to Siri and put in the address and Google Maps takes you there. Or whatever. But the idea is, if you don't have a starting point, all of the directions in the formula don't really help you, right? You need a place to start. The formula is the easy one. That's usually what people get. What they always forget is the starting point. Okay? Let's look at an example. So this is a recursive definition. What's this music from? Polar Express. All right, so we have two parts. We have a starting point, and then we have our formula. Your starting point is always going to be like a sub 1 is 3. It's telling you where you're starting. Your formula, a sub n, is a sub n minus 1 plus 2. So this a sub n minus 1, this is just notation that means the last term. What was the last term? So if I want to find the second term, now this first one here, I'm going to go really slow and write this all out. As we go forward, you won't do this. If I want to find the second term, a sub 2, what is the n? 2. So let's take 2 and plug it in for n. So this is a 2 minus 1 plus 2. 2 minus 1 is 1. So this is a sub 1 plus 2. And what is a sub 1?
3.
3 plus 2. And so my second term is 5.
Oh.
So if my first term is 3, and my formula is add 2 to the last term, and I want to find the second term, that's just my last term plus 2, which is 5. Okay, long way of getting to that.
So you have to know the previous term to get to the next one?
Correct. That is why the starting point is so important. If I would say, you just write down the formula, and I would say, what's the next term? There's no way to get it without having the last term. That's why the starting point is so important. But the starting point's so easy, people always forget it. And they just put the formula, and then they lose a point because they don't have a starting point. Okay? So, how do we find a sub 3? It's going to be a sub 2 plus 2 which is 7. And then what is a sub 4? A sub 3 plus 2 is 9. Now, notice my sequence here. It's 3, 5, 7, 9. What type of sequence is that? Arithmetic. What am I adding? 2. So wouldn't a sub n is 3 from our formulas earlier this week? Wouldn't that be the formula for the nth term? So now we have 2 different formulas for the same sequence. This formula is an explicit form. If you wanted to find a sub 10 here, you would just plug 10 into there, right? And get 9 times 2 is 18, you get 21. If you use the recursive formula, how would you have to find the 10th term? So you'd have to find the 9 and the 8 and the 7 and the 6 and the 5 and the 4. Because this is based on the last term, so you have to know them all. Explicit formula is a little different. Okay. Sometimes one will be easier, sometimes the other will be easier. This one, they're both kind of easy. It just depends. Okay? Let's see if we understand this a little bit. Here is one. Find a sub 2, a sub 3, and a sub 4. I have T's on there, don't I, instead of A's? Do they? Yeah, sorry. Sometimes I use T's, but I just T represents terms sometimes, so sometimes it's you do it the same way. I wrote a sub 1 over there again so we can see it as I go moved up here. What's a sub 2? 5. A sub 3?
14.
And a sub 4?
41.
Let's kind of just talk how we got that. A sub 2 is 3 times the last term, 2 minus 1. 3 is 3 times the last term, minus 1. And 4 is 3 times the last term, minus 1. Now, that's if we just use the last term. Let's kick it up a notch. What does this use? The last 2 terms. So, n minus 1 would represent the last term, and n minus 2 would represent 2 terms ago.
Yeah.
Not the best way to say it. So, what would a sub 3 be? Well, that's going to be 2 times a sub 2 plus a sub 1, which would be 2 times 3 plus 1, 7. See if you can find 4 and 5. They're on your notes. So see if you can find the next two kind of following that pattern. There?
Yes.
That would be
41.
wow. Surprised you got it?
Yeah.
So let's say we are given a sequence.
No, here we go.
Write the recursive formula. Now, first off,
There's one.
what do you mean?
The one where we have to do.
So if we want a recursive formula, we need two things. What do we need? Starting point. So we need to know what a sub 1 is, which is 3. And then we need to write the formula. And once again, you have to look at how do you get the next term? You add 4. So what's my formula going to be? It's just going to be my last term.
Oh, no, geez.
In some ways, that's easier than doing the explicit form, right? Because what's the next one has to do? What is the explicit form? What type is this? Arithmetic. And do we all have those formulas memorized yet? I'm going to say as we get to like tests and quizzes next week on this, you're going to get a formula sheet, right? You're going to be able to put all this stuff down so you don't have to remember it. But our formula for explicit is a sub n. Let me write it over here. A sub n is a sub 1 plus n minus 1 times d. Right? That's from the notes yesterday and the day before. So a sub n is 3 plus n minus 1. What's my difference? Which way is easier, explicit or recursive? They're both not that difficult, right? What about this one? So can we write it both recursively and explicitly? I'll let you try that. You guys have different in your notes. Well, your notes, I say recursive first, explicit second, don't I?
Yeah.
So I'll do that to make it the same. Give you a second to try that, and then we'll. What do we get for the recursive? First off, we need our starting point. Did anybody forget the starting point?
I didn't.
Bryce did.
Price tag.
Bryce did.
Bryce is the only one I can see right now, so I'm sure that a lot of you did too.
I didn't.
So, so what's the formula? To get the next term, all you gotta do is figure out the pattern, right?
Yes.
To get the next term is just divide by 2 or multiply by 1/2. Either way, however you write it, divide by 2, multiply by 1/2, that's all you need.
Okay.
If we write it with explicit, it's a sub 1 times r to the n minus 1. That was our formula. That was also a formula we looked at earlier. What about this one? Perfect squares. Perfect squares.
Yes, sir.
So, which one's easier?
Probably explicit.
No, it'd be explicit.
So, what would be the explicit? Let's do explicit first. Remember, thinking of our pattern, this is n equals 1, 2, 3, 4. So, what would be our explicit formula? For 5, what would it be?
25.
For 6, what would it be?
36.
So for n, what is it?
N squared.
Just square.
Oh.
Yay.
Pretty simple. Recursive?
No.
A little harder. Because we have to figure out add 3, add 5, add 7, add 9, add 11. How do you do that?
Can't.
You can. It is 3, 5. Notice when we want to find 4, we add 7. When you want to find 6, you add 11. So this is 2n minus 1. And that is not like trivial, obvious to get that. Okay, that's tricky. So for this one, it's explicit is much easier than recursive. But consider one more. Which sequence is that? Fibonacci's. What would that be as recursive?
Would be what we did.
Up top, right. So how many starting points would you need for Fibonacci's?
2.
You need 2. So you'd say a sub 1 is 2, a sub 2, excuse me, a sub 1 is 1. This isn't on your notes because I'm not going to expect you to look at this one. And then our formula is you had the last 2 terms, right?
Mm-hmm.
And I told you before, is there an explicit formula for this?
Almost.
There it is.
Jeez.
Wow.
I was like, yeah, that's obvious. I mean, how hard is that?
Well, of course.
How did I get that?
I mean, well, that's
Someone else gave it to you.
Wikipedia.
Really?
Yeah, that's where I got that from. Yeah, that's Wikipedia. So you can tell I took a picture of it. I didn't even write it down myself. I just took Wikipedia and took a screen capture of it and posted it there. So. And I show you this just to show you, as you look at your notes, the 3, 7, 11, 15, both ways weren't bad. We could do it either way and you'd be fine. As you look at 1, 4, 9, 16, explicit was pretty simple, recursive was harder. Here, all of you understood the recursive part, but the explicit was like impossible for all of us. So it just depends on the sequence. Some, you can kind of do it either way, recursive or explicit. Some recursive is easier, some explicit is easier. It just depends. And this has something to do with the golden ratio. This 1 plus square root of 5 over 2 is golden ratio stuff in there, and it's really, yeah. So much harder than we'd ever, I don't know how they figured that out. So somebody way smarter than all of us figured that out. So, all right, non-math here, just a English kind of question for you.
No.
So, and there's not a wrong answer here. Well, some might be wrong, but generally not a wrong answer here.
Frog.
If I said in your own mind and thinking of words here, what is the difference between a sequence and a series? Don't think math. Just say, okay, when you say the word sequence, I think of this. When somebody says the word series, I think of this. What's the difference?
Think of a reoccurring pattern. In a series, I think of like something similar, but it's not like reoccurring.
When I think of series, I think like movie, like 1, 2, 3, 4. When I think like sequence, I think like what the like people are going to be coming out of a doorway or something. Like what sequence they're coming out in, that kind of thing.
Okay.
I think order. Let's see.
Say it again.
I think of order, but let's see.
Big things in order, like we talked about. And then series, I mean, I think when I think series, I go to sports.
Yeah.
Right? I think like
I
the
think
playoff
of TV
series
shows.
or World Series or something like that. That's what my mind goes
I
to.
think of TV.
Or TV series, right? You binge watch a whole series on Netflix or whatever.
Oh yeah.
Something like that. And I guess we don't really use sequence in those, but in some ways, you know, if I said, would you think of a difference if I said, well, because of this sequence of events, something happens? Or if I said because of a series of events, something happened. Does one of those sound right and one of them sound wrong, or they're both kind of like, okay, either one sounds okay?
Serious sounds better.
Series sounds better.
Sequence sounds better.
But-
Sounds more like
The point is, in that kind of context, there's not a huge difference, right? They kind of mean the same thing. So the next thing we want to look at is how a sequence and a series are different mathematically. And they are, okay? And I'm not even going to pass out the notes to you because we're only going to do the first part here for a minute or two, and then we'll finish it. We'll continue with this next week. But just to kind of get us thinking about this. Here's the difference. I'm going to show you the difference, and then you can see if you can determine what the difference is. So first off, here's a sequence. And there's two types of sequences we can have. We can have an infinite or a finite. And what does finite mean?
and constant.
Finite means it ends. There's a set number. How many terms are in the first sequence? 5. How many are in the second? Infinite. That's all it is. Finite means it stops. There's a set number. Infinite basically means not finite, which means it goes forever. So, some ways you could think of finite as not infinite, which would be not finite, which doesn't really help you. It's like defining a word with the word itself, but still, it gives us an idea. We all understand infinite. Finite's a little harder to understand. Here's a series. How is a series different than a sequence?
Expands.
This is expanded, but what's different between these? You're just adding them up.
Make it more complicated.
A sequence is a set of terms. A series is just those terms added together. Now, what does the expand part mean up there? This is a series expanded. if we evaluate a series, this is the expanded series. If I evaluate them, they add up to 30. This is an infinite expanded. Can I actually write them all out? No, they're infinite. But can I add them all up?
Not really.
If you add them all up, they equal 1. How does that work?
Because they're moving smaller and smaller.
How can you add up an infinite number of things and get a number?
Because there's
It's like turning on the spigot of water and water continues to go into the bucket forever, but the bucket never overflows.
That's holes.
No, there's no holes.
doesn't.
You just keep putting water in forever and never overflows.
It's just a guess.
No, it's.
Who did
The Wikipedia
who did the
today.
math to equal 1?
Did you screenshot that?
Actually, you've seen this already.
Oh, really?
Yes.
Yeah.
Probability.
You did it with Patrick.
Patrick.
One of the last things you did was the sum of an infinite geometric series. With Patrick.
Yes.
And you had some formulas. Because
Remember how they broke it
Also,
that we'll get to starting next week. Okay. Looking ahead to next week, we have 3 days probably, Monday, Tuesday, Wednesday, of new material. We're going to review on Thursday. And I'll just warn you now, that's a big day of review because there's going to be
Like 3
all of this stuff, sequences and series.
plus all of
And I'll look and see how your quizzes go and whether or not, right now I'm planning on throwing all the conic section stuff on that test next Friday.
and we will have a formula sheet.
And you'll have I think I'm going to give you one piece of paper, let you write whatever you want on it.
It's not
Piece of
that bad.
paper.
Formula sheet, it's not bad. Just gotta plug the stuff in the formula.
In some ways, I almost want to go open note,
Yes.
but I don't like open note because if I say open note, your brain hears I don't have to study.
Yeah,
Trying to.
So if I at least say you get one sheet of paper, front and back, anything you want to write, it at least forces you to write stuff down, and then maybe something will stick in your head. Because as soon as I say it's open note, you translate to I don't do anything. I'll just show up and wing it.
Yep.
So.
Shall I do it way, not the line?
You're gonna wing it. So by at least giving you one sheet of paper, front and back, anything you want to write, it's going to force you to at least think about what you want to write. So that's kind of what we're doing.
Right.
Right.
Everything.
All right, homework. We have
One.
Did I give it to you?
That paper
Yeah, we have the
yesterday.
sequences I gave you.
This paper.
Because yesterday you were only able to do the front, basically, right? Now if you look at the back, and that's all of the recursive and explicit recursive formulas and that kind of stuff is on the back. Okay, that will be due on Monday. And I look at end of the semester, it's kind of like, anybody run track? Okay, I look at the end of the semester like you're running a race in track.
Gotta finish strong.
Sprint to the finish. It's not like you get to the end and you slow down and you just coast across the finish line. It's like
That's what it feels like.
I'd use
So-
all my fuel in that 400.
And this is like the last 10 yards. It's like absolute. You speed up. I always say the end of the semester is like running downhill. You just keep going faster and faster. If you
You
trip,
just fall.
You're done.
you face plant. It's bad. But if you keep up, you can go run really, really fast. So we're running downhill here for the next 2 weeks. So do your best to keep up. Hope you don't crash and burn. So
Maybe. Can I have a copy of that?
yes.
And I as well.
No.
No. Yeah.